Hello my dear students, hope you all might have understood the concept of last class thoroughly, that is banking of road and level road. We have discussed in brief about the banking of road, level road and the velocity, that is maximum velocity we have calculated. So on that basis we have done some numerical also. In today's class we will be focusing on solving problems in mechanics. How to solve the problems in mechanics. Some of the points are very much important while doing the problems in mechanics. So what are that points? First is we will be using the Newton's laws of motion, that is Newton's second law of motion, second law of motion, that says net external force is equal to ma. To the second, we will be using Newton's third law of motion also, that is Newton's third law, it is f of AB is equal to minus of f of BA, or simply we can say to every action there is equivalent opposite reaction, that is why it is minus, that is action is equal to reaction. And the third one, and which is very important also, that is Fbd diagrams. What is Fbd diagram? That is called free body diagram. Free body diagram. In most of the questions we will be facing the complex questions and the diagrams. In that questions we need to separate a particular portion and calculate upon that, and similarly we will be using all the collected equations and solve it in a simple method. Let us see the situations when a 4 kg mass object is placed here. What is the downward action? That is mg, that we can take 4, that is 40 Newton approximately. Throughout the class we will be using g is equal to 10 meter per second square. Throughout this session we will be using g is equal to 10 meter per second square for easiness of calculation. So what would be the normal reaction? This is the normal reaction, it is perpendicular to this action. So action is equal to reaction, there is no change in the position of the object, that is the object is at rest. In the case of rest, n is equal to mg. N is equal to mg. Consider another case, similar one, same 4 kg block is there, downward that is 40 Newton, upward normal reaction is there. Say it is moving with acceleration 2 meter per second square, 2 meter per second square. So it is moving downward, so A is downward, we can write 40 minus n is equal to ma. 40 minus n is equal to ma. So ma here is 4 and A is 2. So 40 minus 8 is equal to n normal reaction, or we can say n is equal to 32 Newton. If suppose it is moving upward, suppose moving upward, A is equal to 2 meter per second square, then what will be the condition? That is n minus 40 is equal to MA, that is equal to 4 into 2. So 40, N is equal to 40 plus 8, N is equal to 48. So by the simple equations we can understand, according to this it is moving downward, so 40 minus N is equal to MA, because the direction is downward. If the direction is upward, means obviously N is greater than this 40. So obviously N minus 40 is equal to MA, that is 4 kg into 2 meter per second square. So N is equal to 40 plus 8, that is N is equal to 48. This is a quite simple example. We can draw and separate it and draw the diagram, that is called the free body diagram. Let us proceed with the numericals one by one. Let us discuss the type 1 questions, that means motion of bodies in contact. That means all the bodies which are experiencing force or in motion are in contact. Let us take an example here. 3 bodies are there, say A, B, C, which are in contact, and their masses are 4 kg, 2 kg and 1 kg. Say 14 Newton force is applied in this direction. 14 Newton force is applied in this direction. We need to find the acceleration and reaction between the A and B body. First, let us take A. We need to find the acceleration. We know the formula F external is equal to MA. Obviously, A is equal to F external by M. So F external force is 14 Newton here. So 14 divided by mass, that is total mass, that is 4 kg plus 2 kg plus 1 kg, 4 plus 2 plus 1, that we can write 14 by 7, that is equal to 2 meter per second square. So using the formula external force is equal to MA, mass into acceleration. So acceleration is equal to F external by mass, total mass, that is 14 by 4 plus 2 plus 1, that is 14 by 7, that is equal to 2 meter per second square. We have calculated acceleration. Second is reaction between A and B. This means here we have to find the normal reaction. Say we are drawing a free body diagram, normal reaction in this direction and the applied force is in this direction, 14 Newton. Since the body is moving in this direction, we can write 14 minus N is equal to MA. 14 minus N is equal to MA. So 14 minus N is equal to mass is 4 kg into acceleration already we have calculated, that is 2. So 14 minus 8 is equal to N. So N is equal to 6. So this is the normal reaction. This is two bodies are combined and it is acting upon 4 kg body. So the normal reaction is in this direction. So force applied, external force applied is in this direction. So net force will be 14 minus N is equal to MA. 14 minus N is equal to M into A, that is 14 minus 8 is equal to N, N is equal to 6. This is how we can calculate the motion of bodies in contact. Let us take the second type, motion of bodies connected with string. Earlier what we have seen, motion of bodies in contact, that means all the bodies are in contact. In this case, motion of bodies connected with string. In the same example we can take here, that is 4 kg block, 2 kg block and 1 kg block which are connected with a string. An external force of 14 Newton is applied. What we need to find here is find A, acceleration. Acceleration, we know A is equal to F external by mass, total mass. F external is, we know, 14 Newton divided by total mass is 4 kg plus 2 kg plus 1 kg, that is 7 kg. That comes to be 2 meter per second square. Okay. In the second case, B, we need to find the tension. So, this is the block, first block of 4 kg. Tension is in this direction. What will be the counter action? That is in this direction, that is MA. Using this Fbd, we can write straightly T is equal to MA. T is equal to MA. So, M is equal to 4 kg into A is equal to 2, that is tension is equal to 8 Newton. Tension is equal to 8 Newton. So, in the string cases also we can find it using the formula F external by total mass, that acceleration comes to be 2 meter per second square, and the tension in the first block, that is 4 kg block, is in this direction, and the counter force is MA in this direction. In this case, T is equal to MA. T is equal to MA means 4 mass into acceleration 2, that is T is equal to 8 Newton. Last two questions are based on horizontal direction only. The force and the tension force we have calculated horizontally only. In this type of questions, downward and upward forces are applicable. Let us take two blocks, that is 4 kg block and a 2 kg block, and acceleration is in this direction and 120 Newton is above, and counter reactions are 40 Newton and 20 Newton, that is mg, m into g, g is equal to 10 we have taken 40, and 2 kg 2 into 10 20 Newton. Okay. Here we have to find the acceleration. So, before that we need to find the net external force. So, net external force is equal to, since it is in upward direction, we have to take this first. So, 120 Newton minus, both are in downward direction. So, 40 Newton plus 20 Newton, that is 40 plus 20 Newton. Obviously, it is 120 minus 60, that is 60 Newton, that is 60 Newton. Next is mass, m is equal to m1 plus m2, that is 4 plus 2, that is equal to 6 kg. 6 kg. Now, we can use the formula A is equal to F external by total mass. F external is 60 Newton divided by total mass is 6 kg. So, we can have 10 meter per second square. This is the acceleration. Next is type 3 pulley mass system. It is a pulley and two blocks are placed like this, that is 10 kg and 5 kg. And in this case, the action, that is the acceleration, is downward, and in this case acceleration is upward. That means it is pulling and it is going above. Okay. So, 5 kg, what will be the mg, that is downward, that is 50 into 10, that is 5 into 10, that is 50 Newton. In this case it is 10 kg, that is 10 into 10, that is 100 Newton. Using the earlier formulas, A is equal to F external by mass, that is shortcut, that is F external can be written F external is equal to 100 Newton in this direction and 50 Newton in this direction. So, what will be the net external force, that is 100 Newton minus 50 Newton, that comes to be 50 Newton. So net external force is 50 Newton. What is the net mass? Mass is equal to m1 plus m2, that is 10 plus 5 kg. So that is equal to 15 kg. Using this formula, A is equal to F external by mass. F external is 50 divided by mass, that is 15. So that comes to be 10 by 3 meter per second square. This is the shortcut method. Just we need to find the net external force and the total masses. Formula handy we have, F external by mass, that is 50 by 15, that comes to be 10 by 3 meter per second square. Let us see the normal method using the free body diagram. Let us take the separated diagram. 5 kg, this is 5 kg block, downward force is 50 Newton, that is 5 into 10 Newton, that is 50 Newton, mg, that is mg. And what is the tension? That is opposite to that. What is the direction of acceleration? It is going above. So in this we can write, since it is going along up, so we can write T minus 50 is equal to ma. T minus 50, that is in this direction, that is why we are taking T minus 50 is equal to ma. Similarly, in this case, that is 10 kg, the downward force is 10 kg, that is 10 into 10, 100 Newton, that is mg. What is the opposite direction? Tension. So the direction of the acceleration is downward. So we have to take reverse, that is 100 Newton minus T. 100 minus T is equal to ma. So we can write 100 minus T is equal to ma. So in the second case, it is 100 minus T is equal to ma. Let it be equation number 1 and this is equation number 2. Now adding equation 1 and 2, adding equation 1 and 2. So T minus 50 plus 100 minus T equal to ma, that is mass 5 kg, 5a plus here it is 10 kg, so 10a. Okay. This T will get cancelled. 100 minus 50, that is 50 is equal to, taking a common, we will be having 15. So a is equal to 50 by 15. So a is equal to 10 by 3 meter per second square. So we got the same answer, 10 by 3 meter per second square, here also 10 by 3 meter per second square. So in this we have used the shortcut method, simply using acceleration is equal to net force divided by the total mass, and we got the answer 10 by 3 meter per second square. In this normal method of solving complex problems, taking separately and drawing a free body diagram and making two equations and solving that, we will be getting the same answer. That is, here in this case 50 minus T minus 50. Why T minus 50? Because the direction of acceleration is upward. So T minus 50 is equal to ma. See, in this case the acceleration is downward. So 100 minus T is equal to ma. Simply adding these two equations 1 and 2, on solving for A, we will be getting 10 by 3 meter per second square. So we have seen the shortcut as well as the normal method also. We have got the same result. Let us take another question related to pulley system. A 2 kg block is placed here horizontally, and using the pulley a 3 kg block is placed here. Now the direction of acceleration is in this direction. We need to find acceleration and find tension at block B. This is the question given. So we know the formula, A is equal to F external by total mass. Okay. What is the external force? That is 30 Newton mg. 30 Newton divided by total mass is 3 kg plus 2 kg, that is 5 kg. So 30 by 5 is equal to 6 meter per second square. A is equal to 6 meter per second square. So in the second case, find t at B. Since the acceleration is downward, 30 minus t is equal to ma. So 30 minus t equal to mass 3 into A, we have calculated 6. So t is equal to 30 minus 3 6 are 18, that is t is equal to 12. T is equal to 12 Newton. In this case, we have not calculated the mass of this 2 kg. Why? Because it is parallel and it is in this direction. The mass which is affecting is 3 kg, that is why we have taken 3 into 6, that is 30 minus 18, t is equal to 12 Newton. Next is, in a triangular wedge, 2 blocks are placed as such in the two ends. This is 2 kg and this is 3 kg, and the component of in this direction, that is mg sin theta. So mg sin 30 degree is given. So 3 into 10 sin 30 degree, and here in this case mg sin 30, that is 2 into 10 sin 30 degree. We need to find acceleration. Acceleration is equal to F external by mass. So what is that F external here is equal to, this is 3 into 10 sin 30 degree minus 2 into 10 sin 30 degree divided by total mass is 2 plus 3, that is 2 kg plus 3 kg. 3 into 10, 2 into 10 sin 30. So straightly we can write 10 sin 30 degree divided by 5. So 10 into sin 30 value is 1 by 2 divided by 5. So this will get cancelled. So 5 divided by 5, that is 1 meter per second square. So acceleration is equal to 1 meter per second square. This is how we can solve such type of problems. It is a different type of question, that is type 4, variable mass system. In the earlier questions there is no change in the mass, but cases are also there in which the mass is changing with respect to the time with some velocity. So such type of questions may be solved using this formula, that is F external is equal to ma plus v dm by dt. That is, already we have got F external is equal to ma. In addition to that, we need to add the velocity multiplied by dm by dt, where v is the velocity of the ejected fuel or material. How much it is ejected, that velocity is the v here, and dm by dt is the rate of change in mass, either it is reduced or increased, the rate of change of mass. So collectively, making use of this formula, we can calculate the acceleration in which the body is reducing its mass, or simply we can say variable mass system. Let us consider a question here. It is a conveyor belt, it is continuously moving with a constant velocity, and here funnel is there through which sand is poured in a bag. In a conveyor belt, a bag is placed and the sand is filled in an equal manner. So the conveyor belt has to be in the constant velocity so that it is pouring the sand uniformly. In this case, what we need to find is F external we need to find. So, making use of this formula, F external is equal to M into A. What will be A here? A is equal to 0. A is equal to 0. Why? The conveyor belt is moving with constant velocity. If the velocity is not changing, obviously acceleration will be 0. 0 plus V dm by dt. So, F external is equal to V into dm by dt. But rate of change in mass is given, that is m kg per second. So, we can write F external is equal to V into m. V into m. This is the formula by which we can calculate the velocity external force which has to be given so that the conveyor belt is moving constant velocity. So, F external is equal to V into m. Let us take a rocket problem. This is a rocket, it is ejecting the fuels. Here in this case, V dm by dt is the thrust force, that is thrust force given downward, and V is the velocity of the ejected fuel. That means how much velocity in which the fuel is ejected. Let us take in this question given fuel burnt rate is equal to 1 kg per second, that is 1 kg fuel is burnt per second, and velocity of fuel ejection, that is the velocity with which the fuel is ejected is 60 km per second. We have already calculated that F external is equal to V into m, velocity of the fuel ejected with the mass ejected. So, we can write V into m. So, velocity is 60, the fuel burnt rate is 1 kg, that is 1. So, this is 60 kilometer per second into 1 kg per second. So, it can be written 60,000 Newton. So, the external force comes to be 60,000 Newton. In such type of problems, we have to solve by F is equal to V into m, velocity of the fuel ejection into fuel rate of burn is equal to given 1 kg per second, that is V into m, we can solve easily. Let us take another problem. A rocket with acceleration 20 meter per second square and mg downward, acceleration upward. What is given? Mass of the rocket is 5000 kg and velocity of the fuel ejection is 800 meter per second, and acceleration of the rocket is a is equal to 20 meter per second square. What we need to find here is gas ejected per second, gas ejected per second. In this case, F external is equal to minus mg. F external is equal to minus mg. Why? Because the direction is opposite, acceleration is opposite to this. So, F external is equal to minus mg. We know the formula, F external is equal to ma plus V dm by dt. Okay. So, in place of F external, minus mg equal to ma plus V dm by dt. ma plus mg divided by V is equal to dm by dt. m a plus g divided by V is equal to dm by dt. What we need to find? The rate or the mass at which it is reduced, or simply dm by dt we need to find. So, dm by dt is equal to m, mass is given, that is 5000 into a is given 20, plus g 10 divided by velocity, that is 800 dm by dt equal to 5000 into 30 divided by 800. Cancel, this also cancel. We will be having 3 into 500, that is 1500 divided by 8, that comes to be 187.5, that is kg. That is dm by dt is equal to 187.5 kg, that is the rate at which the mass is reduced is 187.5 kg. So, we can solve such type of problems. So, in today's class we have seen motion of bodies in contact and connected with the string we have solved, and pulley mass system, that on that basis we have solved 2-3 questions, and finally we have seen variable mass system also, that is rocket problem we have seen, and conveyor belt question also we have seen. We have done numericals also. So, altogether hope you all might have understood the concept of this solving problems in mechanics, and if you do the problems on that basis, it will be quite easy to solve the problems, and hope to see you in the next class. Thank you.